You see, you see how great the power supply is working? Hi guys, you are watching channel Mr. Electron, and in this video I'm going to make a high current 300 amps diode. This can, of course, is a part of this project. Here as you can see that there are 50 diodes in this strip of MIC with a single diode rating of 400 volts max and 6 amperes continuous maximum. And one single diode can carry a high current pulse of up to 400 amperes, obviously for a very short duration, but yes, it can. Here as you can see that I'm cleaning the ends of the positive and negative terminals of each and every diode. That is because the ends were stuck to the paper with a glue, which might have some insulation and create a problem during soldering. And guys, this cleaning is also going to remove the oxide covering on the terminals. So after completing the cleaning process, which I did with the sandpaper, let's proceed further. Now guys, here as you can see that I'm gluing the diodes together to create one set of 25 diodes, and in total I have 50 diodes. So there is going to be another set, a second set, which is also going to contain 25 diodes. So two sets with 25 diodes each, with the current carrying capability of each set being 150 amps and peak of 10,000 amps. Now comes the connection part. With a peak value of up to 20,000 amperes and an avalanche breakdown voltage of up to 400 volts. So guys, for doing the connections, first we have to bend the terminals of all the diodes to bring them together to the center terminal for the diode in the center so that it forms a pyramid, and then solder them properly without leaving out a single terminal, so that all diodes are in contact for completing our target 300 ampere diode set. And guys, note that the pyramid side is the positive side of the diode for both the sets. So guys, here as you can see that the soldering part has completed. The positive terminals of all the diodes are under a short circuit. Now the negative part is left, and the wiring, of course, that is also left. So let's move on to that part. And guys, now comes the part of shorting all the negative terminals of the diodes. I mean two sets of the diodes together, negative to negative. And this shorted part will create one overall negative terminal. Okay. So what I will do is I will use little soldering on the outer section, and on the inner section I will place bare copper wire to connect the terminals. And I have to connect each and every single terminal. So guys, the soldering for all the diode terminals is fully complete except for the 3 terminals in the middle. You see the 2 in the middle, those 2 are not connected. Similarly, there is another piece. I think now you can see that's the second. That's the third. Okay, so leaving out the 3, all of them have been connected perfectly with the help of the soldering iron. But don't you worry, because I am going to connect those 3 as well, not with the soldering iron but with a copper wire, and then I'm going to use that copper wire to connect all the terminals together by winding it around these terminals. Well guys, here as you can see that I have perfectly completed the shorting part of the common negative terminals of all the diodes. Now let's place this hot glue. Okay, so let's cover it with this insulation tape because it can create contact with the aluminum boundary and thus create a short circuit. So guys, this terminal that you see is the final overall output negative terminal of this diode. Now I have to think about the positive, and this is one positive and this is the other positive, and they have to be joined together as one with this wire. Well guys, it's time to place this high amp diode inside this can. Okay. Well guys, here as you can see that I have covered this part with tape to protect any short circuit condition, because there is going to be high current which might even burn the can, and because it is aluminum. And this is the cap. I'm also going to place some insulated tape on this, on the sides of this. Okay. Yeah, so the short circuit protection has been completed. All I have to do is place it in. Well guys, our high current diode is fully complete now. It's time for us to test it. So guys, first I'm going to check the forward bias voltage. Okay, well this multimeter can also check the diodes. You see the diode sign. Okay, so red is positive and positive is the black side and negative is for the silver side or gray side. Okay, and here as you can see that it's showing 0.458 volts forward voltage drop. Okay, and in the reverse you can see that it is showing open circuit in the reverse bias condition. Okay, so guys, link for this product will be in the description if you want to buy it just in case. And guys, a few days back you saw me make this variable 24 volts power supply, 24 to 48 or 49 volts DC. So I'm going to test this high current diode with this power supply. So guys, this side of the diode is positive and this terminal from the power supply is also positive and red indicates positive. So let's connect it. Okay, positive terminal has been connected. And guys, this is, as you can see, a 24 volts DC 500 watts output with a current rating of around 27 amperes DC motor that I have for e-bikes. Well, I'm going to test this diode performance with this motor first. Okay, so yeah, this one black one is negative. Okay, and the positive will be connected to this terminal. At present I haven't given any power supply to the to this power supply circuit board, so let's do that. Well guys, the power supply has been turned on. Okay, so turning the knob. Yeah, around 80% of the power. Okay. You see, you see how great the power supply is working. Well guys, this is the forward bias voltage. Okay, let's reverse it to ensure that there is no short circuit inside. And as you can see that in the reverse bias condition it is not working. The diode is working just as any other diode. And one more thing guys, that the high current diodes are very expensive if you have to buy, and this one went really cheap. Now guys, I'm going to run this pump. This is a DC shunt motor and it is going to like this power supply is going to feed this pump to both field winding and the rotor winding because it does not has any permanent magnets, and that is why it is going to draw huge current. Well guys, I'm going to measure the voltage that this power supply is producing, which as you can see is around 37 volts. So obviously this motor is going to draw even more current because of more voltage being fed to it. Yeah, one terminal is connected. Now the other one. Okay, you see, so much spark. So the diode is working pretty good, guys. Now let's move on to the final starter motor, bike starter motor that I have, you all know. Okay, so that's the final before ending the video. You see, it's almost a short circuit. So guys, yes indeed, this diode is working really good, and it is also super good if you want to use it in car alternators, because the car alternators generate huge current at less voltage, and this diode of course can withstand it.